Okay, similar triangles, example number 3. It says, prove that the following two triangles are similar and write the similarity statement. So over to the side, it says here, if you have trouble seeing which sides correspond, ask your teacher for a tip. So all I do is I look at one triangle and I'll see the biggest side. So in this case, E to G is 33. That's the largest out of these 3 different sides. So the largest on this one is 11. So I'd make sure that I line up those two. So I'm going to put the big triangle on top and then the smaller triangle below. So the first one, I'm going to say E, G is over top of, we said this one was the biggest on the small, so I'm going to write T, T, U. So right now, we're going to have 33 over 11, and when you divide that, you will get 3. The next one, I'll go to the next biggest side, so that's right here, E to F. So I'm going to write E to F, and E to F, the second biggest one on this triangle, is T to S, so I will write T to S, and we have, E to F, is 25.5, and T to S is 8.5. In your calculator, 25.5 divided by 8.5 gives you 3. The last one will go to the smallest side. So the smallest side of the biggest triangle was 12, and that's from F to G. So we have F, G, over the smallest one of the small triangle, which would be SU. So FG in this case is 12. So we have a 12. SU in this case is 4. So I'm going to have a 4. 12 divided by 4 is 3. Now, this is exactly what we're looking for. Each one, the ratio is the exact same. So, we have just proved that the two triangles are similar. So, now we just have our therefore statement. So, therefore, triangle will keep the order the same. So, from big to small. So, I'm going to do E, F, G, so triangle E, F, G is similar. I'm just going to write it down here so I don't run out of room. To triangle T, I already used T down here, so I'll go S, and then U. So T, S, and U. The end.